So we've seen that Python could be considered as a model of computing. So with this model of computing, we might want to know, can we compute every function using this model? So to answer this question, what we might want to do is look at, say, every single possible Python program we could ever write, and try to figure out whether or not that's going to represent every single function that we could care to implement. So what we can see here is that there's certainly going to be a relationship between the set of Python programs that I could implement and the set of functions that I might care to implement. So when we look at a Python program, that Python program is going to be implementing some function. We can think of that relationship between the program and the function as itself just some other function, where that function is going to map Python programs to the function that Python program might implement. So if we're going to have any hope of implementing every single function using Python, then we need to make sure that this mapping from programs to functions could potentially be an onto mapping. That says that for any function that we might want to implement, we need to be able to find some Python program where the function it implements is that one. So to figure this out, to figure out whether or not we can have an onto mapping from programs onto functions, we can look at the sizes of these two sets. So we know that in order to have a surjective mapping or an onto mapping from programs to functions, we need to make sure that the number of programs is at least as large as the number of functions. So the cardinality of the set of all possible Python programs exceeds the cardinality of the set of all possible functions. If we don't have that, if that can't be the case, so that is there are more programs, or there are more functions than there were programs, then we know that it's impossible for that mapping to be onto, so it's impossible for us to implement every single function using Python. So this now gets at two questions. To answer this question of can we implement every function using Python, we need to answer two questions. The first being, what is the cardinality of the set of all Python programs? And the second being, what is the cardinality of the set of all functions? So first, let's look at the cardinality of the set of all Python programs. So you looked at this a little bit as one of your problems in week 1, but we're going to discuss that again here. So when we look at any Python program, that Python program is essentially going to be represented as a text file on your computer. And in that text file, you're just going to have a bunch of characters. And all of those characters, they can be mapped to zeros and ones. And so we can think of any Python program as being represented by a binary string. So since that Python program can be represented by a binary string, and we showed last week that the number of binary strings is countably infinite, then we definitely know that since every Python program is represented by a binary string, there is a surjective mapping from binary strings to Python programs, so the number of Python programs must also be countable or countably infinite. So to look at the number of possible functions, this starts to get a little bit different now, because a function is just going to be some way of mapping some string that's your input to some string that's going to be your output. Now, the size of a function is going to be potentially infinite, because there's not necessarily going to be a limit to the number of characters that could be in your input string. If we don't bound that, there's an infinite number of potential inputs. There could also be an infinite number of potential outputs. So when we look at the number of ways we could map inputs to outputs, we're looking at combinations of infinite things mapping to other combinations of infinite things. So it's harder to see exactly what's going on here. So to answer this question, we're actually going to need a little bit more machinery. So let's talk about some of that.